In this video, we are going to see the shortest remaining time first scheduling, that is the preemptive SJF. This preemptive SJF, or we can call it as shortest remaining time first. If in this, jobs first enter the ready queue as they come. The process with the shortest burst time starts executing, and when a run, the when the running process enters a waiting state means when a process with shorter burst time arrives, the executing process, that is the current process, preempts. It replaces this shorter burst time process replaces the running process and it starts executing. This is known as the preemptive SJF. This is explained by giving by an example where we have process of P1 to P5, which burst time and arrival time are given here. At time 0, P4 arrives and it starts executing, and at time 1, P3 arrives but P4 continues executing as it has the as P4 has the shorter burst time. It will not preempt and it will execute, but at time 2 P1 arrives but P4 continues executing as it has the shorter burst time. So at time 3 P4 it finishes its execution, and after comparing the arrived process like P3 and P1 based on their burst time, P1 has the shorter burst time, so it starts executing. Time 4 P5 arrives and starts executing as it has the lowest burst time amongst all the processes, so P1 preempts. So this is the difference between the non-preemptive and preemptive approach. If you have not seen that non-preemptive approach video, you can check it in our channel. And at time 5, P2 arrives and starts executing as it has the lowest burst time amongst all the processes. P5 preempts. At time 6, P2 is executing, and at time 7, P2 finishes execution, and after comparing the burst times of the process, P5 has a shorter burst time and this P5 resumes execution. And at time 10, P5 finishes execution, and after comparing P1 and P3, P1 starts executing, and at time 15 P1 finishes its execution. Based on the burst time we can calculate the time, and P3 starts executing, and at time 23 only P3 finishes its execution, since P3 has a burst time of 8. The Gantt chart is given where it depicts it's the graphical representation of the order of scheduling. Using this preemptive approach, the order of scheduling will be first P4, then P1, P5, then P2, P5, P1, and then P3. This Gantt chart also depicts the completion time for all the processes, and from that we can calculate the turnaround time and the waiting time based on the formulas. These times are the measures that are used to assess a particular scheduling algorithm. The turnaround time is for P4, it's 3 minus 0. 3 is the completion time for P4. Then we get the answer as 3, and then similarly we can calculate for all the processes. And for waiting time also, it is turnaround time minus burst time that we can calculate, and from that we can calculate the average waiting time, which is 4.6. And the same example only is explained for this non-preemptive SJF approach. There the average waiting time we got as 5.2, So this normally this preemptive approach has a lesser waiting time than the non-preemptive approach. So this preemptive approach is better. So because we are getting lesser waiting average waiting time. Coming to the advantages, this algorithm makes the processing of jobs faster than the SJF, that is the preemptive non-preemptive approach. Then coming to the disadvantages, here more context switching is done. That is, as process are switched more times in SRTF than in SJF, so this consumes the valuable time for processing. This adds up to its processing time, and this it also diminishes its advantage of fast processing. So subscribe to my channel if you feel contented.